Algebra 2 Honors Lesson 1-4, Solving Inequalities. Alright, here are the objectives. Alright, now when you're solving an inequality, basically you're solving just like it's an equation. The only difference is you have an inequality symbol here. Alright, so just solve it the same way here. Add 12 on both sides. 3x is less than 15. Divide both sides by 3. Alright, so x is less than 5. Okay. So over here we have to distribute first. Alright, here's a common mistake. A lot of students add here first and then distribute. Alright, you have to follow the order of operations. So distribute first. Alright, so just drop down to 6. So we're distributing a positive 5, that'll give you positive 10 minus 5x less than or equal to 41. Alright, combine like terms. 16 minus 5x less than or equal to 41. Alright, minus 16 on both sides. Negative 5x less than or equal to, alright, what's this going to give us? 25. Divide both sides by negative 5. Now when you're working with inequalities, you have to remember, if you divide both sides by a negative number, alright, you see we divided both sides here by negative 5, you have to flip the inequality. Alright, so this will divide out. We get x, flip the arrow, greater than or equal to, alright, negative 5. Alright, so just remember, when you're working with inequalities, if you divide both sides by a negative, or even if you multiply both sides by a negative, you have to flip the inequality. Okay. Alright, so here's a couple more. Let's follow the order of operations, so we distribute. Alright, this side stays the same. It's greater than 2x, alright, minus 10. Alright, and let's say we subtract 2x on both sides. Alright, now it's okay if the variables eliminate, so this cancels here and this also cancels here. Then let's see what we're left with. Is negative 3 greater than negative 10? Right? Is negative 3 greater than negative 10? Yes, it is. This is a true statement. Right? Right. So if the variables eliminate and you're left with a true statement, right, the solution, right, to the problem, right, is all real numbers. Right? Meaning any real number will satisfy, right, this equation here. Okay? So you can plug in any real number for x, right, and it'll always give you a true statement. Right? So if the variables eliminate, right, and you're left with just some some numbers, think about what you're left with. Is if it's true, then the solution, right, is all real numbers. Okay? Let's do this one over here. Distribute. So we have 7x plus 6 less than 7x minus 28 minus 7x on both sides. So we're left with 6 is less than negative 28. Is 6 less than negative 28? Nope, that's false. Alright, if you get a false statement, right, your answer is no solution. Okay? So it's okay for variables to eliminate. You just have to compare and see what you're left with. Are you left with a false statement or are you left with a true statement? Alright, let's take a look at this word problem here. Alright, so there's a band, alright, and they agreed to play for $200 plus 25%, alright, of the ticket sales. Alright, find the ticket sales needed for the band to make at least, alright, $500. So here's kind of a real life situation. Alright, so let's say X represents ticket sales in terms of dollars. Okay, so in order for you to set up the equation, alright, you're gonna take $200. Alright, so even if nobody shows up, the band's gonna get $200. Right, but if people start showing up, you're gonna add, alright, 25% of the ticket sales. So 25% as a decimal is gonna be 0.25. Right, and then X represents how many tickets, or ticket sales, right, in terms of dollars. So 0.25x, right, and the band wants to make what? At least, right? $500. So at least means they have to make greater than or equal to 500. So greater than or equal to 500. Alright, so minus 200 on both sides, minus 200. So we'll get 0.25x is going to be greater than or equal to 300. Alright, let's make this a nice whole number. Right, so let's move the decimal 2 times to the right. Right, so over here we're going to have to move it 2 times to the right. 1, 2, so we're going to have to add 2 zeros. So basically the problem becomes now 25x. Right, it's going to be greater than or equal to 30,000. And just divide both sides by 25. So x is going to be greater than or equal to, right? So what we're going to do is we're going to take 30,000 divided by 25, and that'll give us 1,200. Okay. All right. So the band needs at least $1,200, all right, in ticket sales, all right, in order to make at least $500 profit, all right, for playing. All right, now let's talk about combined inequalities. All right, combined inequality problems. All right, there's 2 types. The first one is a conjunction. All right, these are the characteristics of a conjunction. First of all, it's an AND problem. All right, that's very important for you to remember. A conjunction is an AND problem. 2, the variable, all right, is in between the 2 inequality symbols. All right, the graphs of a conjunction connect. All right, think of the word conjunction, connect, okay, towards each other. And the solutions of a conjunction problem will make both inequality problems true. Okay, so just keep these characteristics in mind when we do the conjunction problems. Alright, so here's an example of a conjunction problem here. Alright, first of all, the variable is in between the 2 inequality symbols. This is a conjunction. Alright, this is a conjunction. How do we know it's a conjunction? The variable is in between the 2 inequality symbols. Okay, so we've got 2 inequality symbols here. Okay, and the variable is in between them. Now, remember, a conjunction problem is an AND problem. Alright, it's an AND problem. So what you're going to do is you're going to split this one combined. Alright, this is called a combined inequality, because what you've done is you've taken 2 separate problems and put them into one. Alright, now we're going to separate them. Alright, so we're going to take this combined inequality and separate it. The first one, alright, the first problem, first part that you're going to split up, alright, is this. So we're going to have -1 is less than or equal to 3x minus 4. And, alright, we write the word and because we know it's a conjunction. Alright, then the second part, alright, is going to be, alright, you notice the middle part is a part of both. Alright, take this, we ignore this now, take the middle still, and then we have is less than 8. So 3x minus 4 is less than 8. And now just solve them separately. Alright, so work it out separately. We're going to add 4 here, add 4. So this will give us 3 less than or equal to 3x divided by 3 x 1. Over here, let's work it out over here. Add 4 is less than 12 divided by 3 x is less than 4. Now we're going to graph, alright, both these solutions on the same number line. So we know we're going to have the solution we're over here at 1. Alright, so let's say this is 0. Alright, so this would be 1. Say this is 2, 3, and 4. Alright, so at 1, we're going to make a bubble. Alright, now since there's a line underneath, we're going to color in the bubble because that means that it counts this point right here, meaning it counts 1 as the solution. Now read it from where the x is. X is greater than or equal to 1. Right? So where the number is greater than or equal to 1, right? Greater than, they're going to the right. Right? Over here, x, right, is less than 4. So we're going to make a bubble at 4. We don't color it in because there's no line underneath. If x is less than 4, where are the numbers less than 4? They're over here. So we're going to go up. Now remember, one of the characteristics of a conjunction, Remember, the solutions have to do what? They have to go towards each other, right? So they connect. They go towards each other, they connect. Okay? So this is your solution. Now a disjunction. Alright? A disjunction problem is an OR problem. Alright? Is an OR inequality problem. The problem has the word OR in it, alright, and the problem will be separated for you already, so it's a little bit easier than a conjunction. The graphs of the solutions will go in opposite directions, alright, or one single direction. Okay, so keep that in mind. And only one of the inequality problems have to be true for a disjunction problem. Okay, only one of the inequality problems have to be true for a disjunction problem. Alright, and you understand what that means when we go over the problem. Alright, so right here, here's an example of a disjunction. How do we know it's a disjunction? Because we see the word OR. Alright, disjunctions are nice because they've separated, alright, they combine inequality into two parts for you already. Alright, it's already separated for you, so you don't need to separate it at all. So basically all you need to do is just solve it. Let's say we minus 5, 3x less than or equal to negative 3, divide both sides by 3. Alright, x less than or equal to negative 1. Over here, let's work this one out. Let's add 2, add x over here, add x over here. So we're going to get 3x, this eliminates, is greater than 6, this eliminates. Divide both sides by 3. X is going to be greater than 2. So now we're going to graph both solutions on the single number line again. Alright, let's always show me where 0 is at. Here's negative 1. Alright, here's 1. Here's 2. Alright, so at negative 1, let's make a bubble. So negative 1, we're going to have a bubble at negative 1, and since there's a line underneath, we color it in. Now if x is less than or equal to negative 1, where the number is less than negative 1, well, they're to the left. Right? For example, negative 2, that's less than negative 1. Or here, if x is greater than 2, right, we're going to make a bubble at 2. We don't color it in because there's no line. If x is greater than 2, where the number is greater than 2, right, to the right. For example, 3, right, that's greater than 2. So we're going to go this way. Okay? Now a disjunction, right, the solutions, they usually go opposite directions. Right? So most of the time they go opposite directions. Right? But they can go in the same direction too. Meaning this one could go to the left, and also this one could also go to the left, or this one could go to the right, and this one can also go to the right. Okay, so keep that in mind.